Okay, so in this video, we're going to go through the 7-2 Law of Sines, day 1 notes. So we'll do Law of Cosines on day 2. So for this lesson, we're going to go through the derivation of a couple different things and talk about how we can set up using sine or cosine for a triangle that's not a right triangle. So remember that SOHCAHTOA requires that we have a hypotenuse. In order to have a hypotenuse, we have to have a 90-degree angle. So if we don't have right triangles, we're going to work through how we can use something called the Law of Sines to find that. So just to give us kind of an idea of how the Law of Sines works, we're going to look at a problem where it's asking us to find the area of a triangle. And so remember that the formula to find the area of a triangle is area equals 1/2 base times height. And so in this triangle, we have a base, but we actually don't have a height. So remember that the base and the height have to be perpendicular to each other. So one way to find the height of the triangle, so if I'm going to use 22 as the base, so if the base of the triangle is 22 centimeters, then that means that the height of the triangle would have to be perpendicular to that. So if I look at angle B and draw a perpendicular line from angle B to that side, that's our base, this would represent the height of the triangle, okay? And so what we need to figure out is what is the value of that height in order for us to calculate the area, okay? So we know that we're gonna use the base B as 22, but we need to figure out what the height is. And so what we wanna think about is this right triangle that we just created. So if I think about the right triangle, the height is the side that is opposite the angle that I know. So I know angle C is 32 degrees. And then the 18 centimeters is the hypotenuse, okay? And so what I can't do is I can't say that 22 is the adjacent side, because only part of that 22 is the adjacent side, because I'm not taking the whole side there, I'm cutting it at the perpendicular. Okay, so only part of the 22 centimeters is adjacent to angle C, so we can't use that piece. So we have to use just opposite and hypotenuse. So if we think about the trig function that involves opposite and hypotenuse, that's sine. So that means that the sine of the angle C, which is 32 degrees, is equal to our opposite side, which is the H that we're looking for, over the hypotenuse of this triangle that we created, which is 18 centimeters. So if I need to solve this for H, that means that I would want to multiply both sides by 18 in order to get H by itself. So that means that H is equal to 18 times sine of 32 degrees. And so since we're using a trig function, we're going to need to use a calculator to figure that out. So remember that we're talking about degrees, so we should be in degree mode. So if we do sine of 32 times 18, that gives us this 9.5 as the answer. So that means that H is about 9.5 centimeters. So now that we know that H is about 9.5 centimeters, we can solve the problem and find the area. So area is 1/2 the base times the height. So the base of our triangle that we were looking at, remember, is the whole base, is that 22 that we ignored during the problem where we were solving for the height. And then the height is what we just found, our 9.5 centimeters. And so if we do half of 22 centimeters times 9.5 centimeters, that gives us about 104.5. And because we're multiplying centimeters together, centimeters squared to represent the area. Okay. So this idea of I can find the height of a triangle and then I have right triangles to work with is how we're going to derive the law of sines. So to derive something means that we're gaining a formula using other formulas that we know are true. So for this, we're going to go through the steps and follow them to get a formula that we're going to use for triangles that are non-right triangles. So for the first step, they're asking us to draw triangle ABC, which we've drawn for you. So notice that I can put the A, the B, and the C on the angles anywhere that I want. However, the A and the B and the C on the sides have to be across or opposite from the vertex that's labeled with the same letter. So notice that angle A is on the bottom left, and so across from that is side A. Angle B is on the bottom right, so across from that, opposite that is side B, and side C is angle C is at the top, so sine C is across from that at the bottom. So they want us to draw the altitude from angle C to side C with length X. Okay, so the same type of thing that we did here from side B, or angle B to side B, we're gonna draw a height from angle C to side C with length X. So if I'm looking at this triangle, they actually want us to do sine for two different angles. So for angle A, if I think about sine, X is opposite of angle A. And if my right angle is here, that means B is the hypotenuse for that triangle. So notice that side C, we cut it into two parts. And so that's the side that we're not using to set up these problems. So if I'm setting up that, then I've got sine of A is equal to X, my opposite side, over B, the hypotenuse. So I can set up sine of A equals X over B. They also want us to do the exact same thing for angle B. So if I think about angle B, I'm looking at the other half of the triangle. So notice that X is still the opposite for angle B, but this time the hypotenuse is side A. So that means that sine of B is equal to opposite, so X over hypotenuse A. So sine of A is X over B, and sine of B is X over A. So one thing that we're going to do is we're going to solve both of them for X. Kind of like we did in the problem where we're finding the height, right? So if I get X isolated, because that's the height of the triangle, for sine, that means that I'm going to multiply both sides by B so that the B will disappear. So that gives us that X is equal to B times sine of A. And then if I'm solving the equation for sine of B, I would multiply both sides by A. So if I multiply both sides by A here, that's going to cancel this A and give me just X. So X is equal to A times sine of B. So then since I have two statements both equal to X, right? So they're each equal to that x value. I'm just going to set them equal to each other. So since they were both equal to x, that means that b times sine of A must be equal to A times sine of B. So in step 4, they want us to divide both sides of the equation by AB. So I'm going to divide both sides of the equation that we have above by AB. So I'm going to rewrite B sine A on top and A sine B for the other side of the equal sign. So what we'll notice happens is that in each of these, the variable in front of sine cancels. So if I'm dividing B times sine of A by A times B, I can reduce out the B, right? So I can reduce B with B. And then same thing with the A on the other side, I can reduce the A with the A. And so what this gives us is that sine of A over A is equal to sine of B over B. So remember that this angle A and side A are opposite each other. So in words, what this means is that the ratio of the sine of an angle to its opposite side is the same for all angles in the same triangle. So I could do this again, drawing a different height and get that sine A is equal to sine C and that sine B is equal to sine C. And over A and over B and over C. And so what this means is that the law of sine states that given triangle ABC with angles A, B, and C and opposite side lengths, lowercase a, b, and c, the sine A over A is equal to sine B over B. And we could use the same method to prove that also is equal to sine C over C. So kind of depending on what I'm given, these ratios will be equal. So I will always be able to pick 2 and set that up to solve an equation. So note that the letters are interchangeable. So the triangle doesn't have to be ABC. The letters are all interchangeable. Oh, that has the E, but right. I think that doesn't have the E. Sorry if I spelled that wrong. So when we look at the back side, we have a triangle PQR. So that means that instead of A, we're just gonna write P. Instead of B, we're gonna write Q. Instead of C, we're gonna write R. Okay, so those letters aren't relevant to the problem. We just change the equation based on that. Okay, so in example B, we have a different triangle. It's called PQR. Okay, so that means that we're going to use P, Q, and R instead of A, B, and C. When I'm given a problem like this, it helps to draw a triangle to use it to solve. So I'm going to draw the triangle over here in the margin just so that I have a little bit more space for the problem because these are a little bit longer. So triangle PQR, again, it doesn't matter how I label. I'm just going to start on the bottom left and go clockwise to label those sides. So PQR. And then let's label with what information they give us. So remember that because angle P is on the bottom left, that means that side P is across from it. Because Q is the top, that means that side Q is the bottom. And then because R is on the right, that means that side R is on the left. Okay. So let's label the angles that they give us and the sides. So they give us angle P is 33. And that angle R is 64. And that side QR, which if we think about QR is actually lowercase p, right? If I look at that, QR is lowercase p, is 8 centimeters. So they want us to find side PR. So side PR, if I look at that, is Q. So this is the one that we're looking for. Okay. So because I'm looking for side Q, that means that when I solve this, I need to be able to use sine of Q over Q because I want that's my answer, right? And so in order to use that, I need to know what angle Q is. Okay. The other one that I use, I have to know both the angle and the side for, okay? So for one of these, it has to be what I know both for, and then the other one has to be what I want to know. Okay, so I'm taking whichever angle I know both of, angle and side, and I'm setting that equal to the one that I want to find. So I want to find Q, so I am setting Q equal to, I know both, notice for P. So I need to do sine of P over P. And so one thing that we'll notice is that I don't know angle Q, I know angle R. So what we have to do before we can find the answer is we have to find the measure of angle Q first. So because I know two sides in the triangle, I can just do 180. Sorry, I know two angles in the triangle. I can just do 180 minus the 33 minus 64. Okay, so if I take 180, because that's the sum of the angles in a triangle, and subtract the two angles I know, angle 33 degrees and angle that's 64 degrees, that tells me that angle Q is 83 degrees. Okay, so I know that this now is 83 degrees. So that's not my answer, I just need it to find my answer. So if I plug in, so I've got sine of P over P equals sine of Q over Q. So let's plug in the two that we know, which is 33 degrees and 8 centimeters. So I'm just going to use the 8, and we'll use centimeters with our answer. And that has to be equal to sine of 83 over Q, because that's the unknown. That's what we want to find. So we're looking for Q as our answer. So in order to solve a ratio equal to a ratio, a proportion, we have to cross multiply. So I will always multiply the one with the variable and put that on the left. So sine of 33, I'm going to multiply times Q. So Q times sine of 33 degrees must be equal to the other diagonal, so the other cross multiply, 8 times sine of 83. So in order to get Q by itself, what we have to do is divide both sides by sine of 33 degrees. So that we can have Q equal to something, okay? So what we're gonna have to do is calculate this. Since we have division, you have to be careful. So if you have a calculator where you can just type it in and make it look exactly like this, one thing that you will probably have to do is that when you type in sine of 83, you'll need to put it in parentheses, okay, before you make this a fraction or divide by this number, okay? So if you're using a calculator where you can type it in and see it, you're gonna use parentheses to indicate that you're done taking the sign of something. Because I'm using the calculator on the computer, that one works backwards like the iPhone calculator, so I have to type everything in kind of in backwards. So I'm doing 8 times sine of 83. So I have to type in 8, 3, and then sine. Okay, so that's 8 times sine of 83. And that equals 7.94. So I'm going to leave that, and I'm going to do divided by, and then I have to type in the 33 sine. Okay, and so that equals 0.5446 is the sine, so that equals to 14.579, all those numbers. So I'm going to round that to the nearest tenth every time, so the first decimal place. So since the 5 has a 7 after it, that means that Q is equal to 14.6. Okay, so when you type this into your calculator, you should get 14.6. And then remember that the units were centimeters. So our answer for this problem is about 14.6 centimeters. So notice that in that problem, we were asked to find a side Q, which they called PR. So remember that a good way to remember those that I didn't talk about is if they're saying, notice it was the letter that wasn't there, right? So side lowercase q is the same as the side PR. So if I was asking for side QR, since the letter P is not in that name, that's the name of it using the lowercase equivalencies. I'm going to draw a line just so that I know where this ends, because this one, these notes will end up a little bit tight. So just to make sure that I have space. So then for example C, we're asked to find the measure of angle B. So this is going to be different in the sense of how I solve, because I'm looking for an angle instead of a side. So I'm going to draw a triangle again. Really, it doesn't matter what my triangle looks like. I just have to make sure that I label the vertices as what it says. So it says triangle ABC, and I'm just always going to do this the same way. So this is B, this is C. Sorry, actually in my notes I have it this way, so let's just be consistent, A, B, C. So that means that side A is across from A, the side that's between B and C. Side B is the bottom, and then side C is the left side. Okay, so the sides across from each other are the lowercase values of the same name. So they're giving us that the measure of angle C is 75. So let's label C as 75 degrees. And then they're not giving us units for these, so that means that we don't need to label them. So side B is 4. And finally, side C is 5. Okay, so remember that when we're setting up the problem, we're looking at what we want to know, which in this case is B. And so we're going to set that equal to the one that we know both of. Okay, so if we think about what do we know both of, we know both for C. So that means that we're going to use sine C over C is equal to the one that we want, and the one that we want is a B. So we need to use sine B over B, right? And so this one, we don't have the problem where we have to find something that's missing first, because we know both for the side, a side and an angle without having to solve anything, and we know the side opposite the angle we're looking for. Okay, so let's plug things in. So I have sine So angle C is 75 degrees. And then side C is 5. So we're going to have sine of 75 over 5 equals angle B is the one we're looking for. So we're going to leave that as just a B over side B is 4. So sine of 75 over 5 is equal to sine of B over 4. So let's start with the one that we need to know. And so we want to know B. So I'm going to start here. I'm going to write this up here just so I have a little more space to solve. So we're going to write 5 times sine of B and then we're going to multiply the other diagonal together to get the other side. That is equal to 4 times sine of 75. So notice that when I do this every time, I'm writing the constant in front of the sine function. And so you should always do that as well, just so that your calculator, you can make sure that your calculator work is correct in terms of you're not multiplying 75 by 4, you're multiplying the whole sine of 75 by 4. So since I want sine B by itself, I need to divide both sides by 5. Okay, so I'm going to divide both sides by 5. So that means that sine of B is equal to this whole fraction. And so what I'm going to do here is I'm going to calculate that. And when I do that, I'm always going to do 4 decimal places. So I'm going to do it to the nearest 10,000th. And so I'm going to plug this into the calculator. So for this one, we're doing 4 times sine of 75 divided by 5. Again, if you can see everything in your calculator, you probably need to put the 75 in parentheses. And you type it just in order as you see it, if you can do that on your calculator. The calculator I'm using for this, remember, is something where I can't do that. So I'm going to type in what I have, which is 4 times sine of 75. So I have to type in 75, then sine. And so 4 times sine of 75 is 3.8 something. And then I'm going to divide that by the number 5. And so that gives us 0.7727. So again, I'm going to do 4 decimal places. It's a 4 after the 7. So it's just going to stay as 0.7727. Okay, so always do 4 decimal places. My suggestion too is that if you have a button that says like answer or ANS, that you use that so that you aren't actually typing in this number, that you're using the original value to find the answer. So remember that what we talked about in 7.1, day 1, when we had problems that look like this on the back of the notes, is that we use the inverse function on our calculator to find the answer. So the difference is, because I'm talking about a triangle, I don't have to use a reference angle to find 2 answers. I'm just looking at the answer in quadrant 1. So that means that to get B, I'm going to take the inverse sine of that value. Okay, so of the 0.7727. And again, I didn't clear my calculator. What I want to do is just evaluate inverse sine from there. So if your calculator makes it where you can write, you're not working backwards the way that this one does, you should use an answer button. So it's usually like second, somewhere next to the equal sign, like second negative or something. If you don't, you can always just type in those 4 decimals, but your number might be a little bit off from mine. So what I'm going to do here is, because I need to take inverse sine of that number, I'm just going to hit second and then sine. And so that'll give me the answer. So remember, our answers, we're always just rounding to 1 decimal. So that means that this is going to be 50.6 degrees. So B is about 50.6 degrees is our answer. Okay, so process is still the same in the idea that I cross multiply, but how I get my answer changes a little bit when I'm looking for the angle, because I have to use the inverse sine function on the calculator. Okay, so for the problem in example D, things are going to change a little bit because they want us to find everything. So notice it says, find the missing angles and sides. So in order to do that, what I'm going to do is, we're going to do this without even drawing a triangle, which is what we could do for all of them now that we've kind of seen the process. So what I'm going to do is just lay out what each of them are equal to. So I know that since it's triangle ABC, I'm going to have an angle A and I'm going to have a side A. I'm going to have an angle B and I'm going to have a side B. I'm going to have an angle C and I'm going to have a side C. So I'm going to put my answers in here as well as the information that was given. So I know it's only asking me for the missing ones as answers, but I'll know which ones we're missing and just check those if this is a test. So I'm gonna write down the ones that they gave us. So they gave us that angle A is 35. I'm just gonna keep those black so I have the visual of what my answers were. I'll do those in color. So angle A is 35 degrees. And angle C is 62 degrees. They also give us that side C is 7 inches, okay? So since we know that angle C is 62 and side C is 7, when I'm solving this to find the missing pieces, I'm always gonna use the one they give us, okay? So I will always use the given pair of side and angle. Wow, I am spelling great today. So even though once I solve for, like, let's say side A, I know side A now, but I used a calculator and estimation to get that. So it's not as accurate to use to find B as C. So in this case, we're gonna use C in both problems. So we're gonna use side C and angle C. So sine C over C to find both A and B. So I'm gonna draw kind of a vertical line just because this is longer. We have 2 problems that we're finding. So I'm gonna give myself, split up my space for both of those. So I know angle A is 35 degrees. So when I'm solving for sine A over A, I know everything that I need, okay? So let's plug those in and figure out what side A is. So I have sine of 35 over, I want to know angle A, or side A, is equal to sine of 62 over 7. So remember that our strategy is that we cross multiply, and we always start with the diagonal that's going to give us our variable. So if I cross multiply that, I'm doing A times sine of 62, and that must be equal to 7 times sine of 35. So that means that to solve for A, I have to divide both sides by sine of 62. So if I check this out in the calculator, I have to calculate 7 times sine of 35 divided by sine of 62. Remember, you might need to put parentheses around your angles if you are using a calculator that does not work like the one that I am showing. So I'm going to type in 7 times 35 sine, and so that is equal to 4.015. Then I'm going to divide that by sine of 62. And so that gives us 4.547. So remember, we're looking at the 4.54. Since 4 is smaller than, is less than 5, that means it's going to stay a 4.5. So A is 4.5. Our units were inches, so that's our first answer. Okay, so we got one answer. We are still going to use sine C over C, but this time we need to figure out the B's. So our problem is I don't know anything about B, so I don't have anything to plug in on that side. So I know that this is going to be equal to sine of 62 over 7, but I need to figure out what's going in for one of those in order to find the other, right? I can't solve something that has 2 different variables. So remember that what we did in the first problem was if I know 2 of the angles in the triangle, I can find the third by just subtracting from 180, right? So in order to find B here, we're gonna take 180 and subtract the 62 and the 35. So if I do 180 minus 62 minus 35, that means that this angle B is 83 degrees. So I now know angle B quite easily because I knew two angles in the triangle. And I want to solve for side B. Okay, so I just need to solve this proportion in order to find my last answer. So remember that we always want to multiply with the variable first. So we're going to multiply B times sine of 62. And set that equal to 7 times sine of 83. And then to isolate B, we have to divide both sides by sine of 62. So that means we have to use our calculators to figure out angle B. And so remember that you might need to put these in parentheses depending on your calculator. If it populates a parenthesis right after the word sine, you have to put in a parenthesis to close it after the 83 and after the 62. Okay, so for my calculations, I'm going to multiply 7 times 83 sine, and that's going to give us 6.947. I'm dividing that by sine of 62, so I have to type in 62 sine, and that gives us 7.86. So since 6 is bigger than 5, we're going to round that up to a 7.9. So 7.9 is the answer for B. So that means that side B is 7.9 inches. Okay, so we found all 3 of the missing sides for that triangle ABC. The last thing we're going to do is an application problem. So in this application problem, they've given us the diagram. So let's kind of annotate it using the words to figure out what we're looking for. So Nicholas is walking along an obstacle course, and he begins at point X and he starts going straight on the path. Okay, so at the start of point X, he's going straight. If we look at the labeling, he's gone 1,200 feet. Okay, so that side is 1,200 feet. Then he takes a wide turn onto a second path at point Y and continues for 1,000 feet. Okay, so Y, he's starting at Y, going to Z. That one's 1,000 feet. And then before turning onto the final path at point Z. So then he turns at point Z and goes back to the building at X on this obstacle course. So they are asking us to find, so what is the angle between the second path and the final path at point Z? So they want us to find this angle, right? That's where our question mark is. So let's label based on what we know. So looking at this, that means that the 1,200 feet is side Z, and that the 1,000 feet is side X. Okay, so we know nothing about angle Y and side Y, so that means that when we're doing the law of sines, we're not going to use the Y's at all. So we know both for X, so we're going to use sine X over X, and we want to know Z, so we're going to use sine of Z over Z. Okay, so let's plug those in using what we know. So let me just set it up with space. Okay, so we know that angle X, if we look at our diagram, is 32 degrees. So sine of 32 degrees over 1,000 feet is equal to sine of Z is the one we want to know over 1,200 feet. So we're looking for angle Z. We know side X, angle X, and side Z. So what we want to do is cross multiply. Since we're looking for Z, let's multiply 1,000 times sine of Z. And set that equal to the 1,200 times sine of 32. So in order to get sine of Z by itself, we're going to have to divide both sides by 1,000. So that tells us that sine of Z is equal to this ratio. So we're going to calculate 1,200 times sine of 32 and divide that number, which is 635.9 by 1,000. And so that gives us, remember, we're going to write this for 4 decimals, so 0.6359. Don't clear it from your calculator, but let's just write it down, 0.6359. And then we have to use an inverse sine function to get the answer. So Z is going to be equal to arc sine of that value. So 0.6359. Actually, it's not equal to, it's an estimation of about. And so we're doing, remember, you're either using the answer button or if you can find it, or just typing in the decimals. For this type of calculator, I can just hit second and then I get the inverse sign. And so that gives me 39.48. That 8, since it's bigger than 5, is going to round this up to 39.5. So the measure of angle Z for my answer is about 39.5 degrees. Okay, so that is the law of sines. Again, the title said sines and cosines, but we will do, we will do law of cosines when we come back on Tuesday. So for this one, you're looking at page 370, numbers 5 to 8, and then on the next page, 18 through 21. So here are the problems if you want to take a picture and pause that or display it for the rest of class. Again, remember that for the first 5, right, you're looking, actually for all of them, you're just looking for the angle or side that's listed. So they are not like example D where we solved for every piece.